Right, in the last video we discussed the fact that the periodic table is divided into things called groups, and we have group 1, which happens to be called the alkali metals, group 2, which is the alkaline earth metals, group 3, nameless, 4, nameless, 5, nameless, 6, chalcogens, but we're not going to make a big deal about that. 7 is the halogens, and 8 or 0, some people will say that's group 0, are called the noble gases. So those are our groups. Now, what happens is that each one of these, we don't need to go into it in great detail this year, we'll go into it in more detail next year, but this has got one electron in its outer energy level. In other words, on the outside there's one electron, on the outside there's 2 electrons, on the outside there's 3, on the outside there's 4, the outside there's 5, on the outside there's 6, on the outside there's 7, on the outside there's 8. So really you just need to be able to count to 8. It gets even easier. You have to do a little subtraction, all right? What happens is that if this guy has got one electron in its outer energy level, or one outside electron, it doesn't really want that one outside electron. It would like to have, everybody wants to be a noble gas. Noble gases are they are perfect. Nobility, it's like kings and queens. They are perfect. They're snobs. They don't bond with anything. They don't connect with anything. But the noble gases then are what everybody else wants to be. So these guys over here will lose electrons to become like a noble gas, lose 2 electrons, become like a noble gas, lose 3 electrons, become like a noble gas, lose 4 electrons and become like a nearest noble gas. Or something like fluorine would just gain an electron to become like its nearest noble gas. Oxygen gain an electron. 2 electrons. Nitrogen gain 3 electrons. Carbon gain 4 electrons. Group 4 might lose electrons. It might gain electrons. We don't really know which way group 4 is going to go. It could go in either direction. Now, you don't need to understand why this happens at grade 9 level, but what you do need to understand is a word called valency. And valency is the number of electrons that will participate in bonding. And you're going to think of that as bonding arms. In other words, how many hands can any element hold? And it turns out that it links to its group number. Group 1, just going to make it a tiny bit smaller so I can scribble. Group 1 will have a valency of 1. Group 2, because it loses 1 electron. Group 2, 2, because it loses 2 electrons. Group 3, 3, because it loses 3 electrons. This is, as you can tell, very challenging. Group 4 has a valency of 4, because it can lose 4 or gain 4. Now's where the trick comes in. Group 5 has a valency of 3, because it can gain 3 electrons. Group 6, a valency of 2, because it can gain 2 electrons. Group 7, a valency of 1, because it can gain 1 electron. And group 8 or 0 has a valency of 0, because it doesn't bond at all, it doesn't participate. Let's look at that in terms of notes. I'll show you how it applies in a second. So, quickly reading the notes, the periodic table is divided into groups. There are 8 groups, as well as the transition metals. The group that an element is in is very important because it helps us decide how it bonds, how it links with other atoms. Every atom has a certain number of bonds. The number of bonds that an atom can form is that atom's valency. And it's easy to remember 1, 1, 2, 2, 3, 3, 4, 4, 5 is 8 minus 5, 3, 6 is 8 minus 6, 2, 7 is 8 minus 7, 1. And group 0 or 8 has a valency of 0 because it does not bond. Usually, we have group 1 to 4 have valencies of 1 to 4, and group 5 to 8 have valencies of 8 minus 5, 8 minus 6, 8 minus 7, and 8 minus 8. The transition metals have what are called variable valencies. They might change. Except for zinc, which is always 2, and I'll show you how you remember that. Zinc, can everybody see that a Z looks a heck of a lot like a 2? Yes, it does. Okay, and then you've got this thing called silver, and it's got the number 1 in the middle of it, and its valency is 1. So that's how I remember it, but it is on your list of polyatomics. the valency of all other transition metals has to be given to me using something called stock notation. Now, stock notation always refers to the element in front of it. So if I put, by the way, sorry, inconvenient, you have to now count in Roman. So stock notation is always in Roman. 1, 2, 3, 4, 5, 6. Luckily, you only have to count to 6 in Roman. Okay, it's not so bad. So now what you're going to do is you're going to say, the valency of this mercury is 2. The valency of this mercury is 1. I just said they've got variable valencies. It can change. Lead, 4. Iron, 3. So the valency always comes for the element in front of it. Let's see how we're going to apply that. So we're going to join. We're going to determine the chemical formula of these 3 things. First, let's look at magnesium. Magnesium is Mg. It is in group 2, which means it has a valency of 2. I'm going to give it 2 arms. That means it can hold 2 hands. 2 electrons will participate in bonding. Oxygen is over there, and it has a valency of, it's in group 6, so it's 8 minus 6, also 2. Now watch what they do in their bond. Hold hands, hold hands. Everybody's hand is held. That is happy as a molecule. The formula for magnesium oxide is MgO. Easy as that. Then if I look at iron chloride, I have got Fe. This 3 tells me that the iron has 3 arms. Chlorine, Cl, is in chloride. She's changed her name, and she is in group 7, and she has gained 1 electron. 8 minus 7 is 1, so she has 1 arm. Let's hold hands. Is everybody happy? No, shame. Look at iron. There's still 2 unheld hands. So what happens is another chloride comes along, hold hands, and another chloride comes along to hold hands until everybody is happy. Now let's write a formula for that. Fe in the picture, Cl, 1, 2, 3 chlorides, so FeCl3. What about something like aluminium sulfide? By the way, notice again that we've got this ide situation. It was oxygen when it's bonded. Chloride, a non-metal, chlorine when it's bonded. Sulfide, the non-metal, sulfur when it's bonded. Oh, that's a very little periodic table. Anyway, let's keep going. We're going to go aluminium. Aluminium is in group 3, which means it has 3 arms. Sulfur is in group 6, which means it has 8 minus 6, 2 arms. Let's hold hands. Is everybody happy? No, they are not. Hold hands. Is everybody happy now? No, shame. Sulfur's sitting without anyone. So I add an extra aluminium. Aluminiums come with 3 arms. Is everybody happy now? Still not. That poor aluminium doesn't have all its hands held. Sulfur comes with 2 arms. Hold hands, hold hands. Is everybody happy now? Yes, everybody's happy. Yay. And we're going to write the formula Al, 1, 2, sulfur, 1, 2, 3, Al2S3. That is how you write the chemical formulae. This page just has a neater version of what I scribbled earlier, so if you want to look at it, you're very welcome, where it clearly explains magnesium's in group 2 has a valency of 2, oxygen in group 6, valency 2, etc., etc. Each valency arm is occupied, 1 magnesium bonds with 1 oxygen, 3 sulfurs bond with 2 aluminiums, so I land up with Al2S3. So this is just a neat version of it all.